Okay, so we are going to lab 14.2. I think some people are missing. This is the lab on Faraday's law. So let's just look at this here. And it says to go, what we're looking for is observing the interactions between the magnetic field and the conductor. So you have to open Faraday's law. By the way, I'm going to be galloping through this because I got 3 labs to do today. So basically, what you're going to do, what you're trying to discover is the kind of things that happen when you move magnets in different ways around a magnetic, around a coil of wire. And then does it change with 2 turns or 4 turns? And so we're gonna start by placing the magnet in different locations and see what happens. And then we're going to move the magnet in different ways and see what happens. And basically what you're supposed to do is just make up a bunch of different things. What happens if it's above the coil and I'm close to the coil and I move it smoothly? What happens if I'm above the coil and close to the coil and I jiggle it? So you just got to do a few of those things. And I'm going to show you just a little bit here. And we're probably only going to take like 5 minutes on this, okay? So there's the FET lab, and we got 1 coil, and I'm going to turn on the voltmeter. You can turn on the field lines too if you want, it's up to you. So the first part of this thing is, it says, start by placing the magnet in different locations. What do you think is going to happen? Well, so part of the point of these labs was that you would learn to discover things on your own, but sometimes it's easier than others. So I don't mind doing this for you. So we're going to place it here, and what happens when I put it there? And then what happens when I put it there? And then what happens when I put it there? And then what happens when I put it there? And what happens, as you can see, I'm going to turn off those field lines because they're getting in the way. What happens is nothing. It doesn't matter where, wherever I put it, when I put it there, once I put it there, nothing's happening, right? So that's basically what happens when you put the magnet in different locations. If that magnet is still, nothing is going to happen. Now let's go down to the other chart. Now we're going to try moving the magnet in different ways. And we'll start out putting it, I'm going to do these 3 for you. We're going to put it above the coil and close to the coil, with the polarity to the right. That means the north should be to the right. Right now the north is to the left, so I'm going to switch polarity. And so now the north is to the right. I'm going to move it in a long, smooth motion parallel to the coil. We're going to see what happens. So I'm going to start over here. I'm just going to go. Okay, so oops, I banged against it. So what's happening in this long, smooth motion? As it goes, you look at the voltage meter. If we didn't have the voltage meter on, all we would know is that there is a current flowing, and we wouldn't know which direction it's flowing, right? But because the voltmeter's on, we can see that when it's in the influence of the south pole, it flows one direction, and then in the north pole, the other direction. So that's what we see there. So that's kind of interesting. And you would write that in the table. And now I'm going to jiggle it left and right and see what happens. So I'm going to put it right there, and then I'm going to jiggle it and see what happens. And this is the whole thing. You're just supposed to be exploring it and saying, what happens if? So what happens if I jiggle it a little? Not much is happening, right? What happens if I jiggle it a lot? What happens if I jiggle it more slowly? Do I get a bigger inflection more slowly, or if it's quicker? It looks like this. I move it more slowly, I actually get a bigger deflection, a bigger current flowing, right? So that is left and right, and so I would have made my prediction about what would happen, and then I write my observation there. What if I put it above the close to the coil and I jiggle it up and down, instead of going like this? Now I'm going to go up and down. Well, now that moves it. It seems to move it about the same. Huh, interesting. And then so you go, okay, now what happens if I put it over here? What happens if I move it up and down? Is it more or less than before? What happens if I jiggle it over here? Nothing. What happens if I put it inside? Oh, you can see what happens if I put it inside, can't you? Is that more? That's a lot more than if it's outside the coil, right? Why do you think that would be? Okay, so and we notice that at first, when the south pole goes through, it deflects toward the positive, and then when the north pole goes through, it deflects toward the negative. Now, when I go this way, the north pole makes a positive, and the south pole is negative, right? So that's kind of interesting. Will that change if I switch the poles? Yep, switching the poles reversed the way it went, right? Now, let's say if we have two different, so we're going to look at this, see how much it moves when I'm moving it like that. When there's 4 turns in the coil, what do you think is going to happen when I move it through this one? Is it going to be more or less? Less, right? Like half. I'm trying to move it at approximately the same speed. So there's something about the amount of wire running through the magnetic field that more current gets moved, the more wire is in contact with the magnetic field, right? Because in a 4-turn coil, there's twice as much conductor in the magnetic field as there is with the 2. So that's one thing to observe. Another thing definitely we want to observe, and probably I would say the main point of this whole lab, is that it's not just that there is a magnet. It's not just placing a conductor in a magnet. The conductor is fully immersed in the magnetic field surrounding this magnet. The thing that induces an electric current in a conductor is not being in a magnetic field. It's being moved through a magnetic field. It's when the magnetic field moves. See, I could. Now that's interesting. See, look, I'm moving it up and down and I'm getting nothing. I have to do it that way. So the conductors have to be perpendicular to the electrical field. So what if I jiggle it right here? Getting a little bit way out there, right? And then the closer I get, and they got a little tease sound there. Okay. So anyway, that's about enough for that lab. That's basically what you're really supposed to discover is that there has to be, and they don't have it in this lab, but you can have the magnet be still and move the conductor and get exactly the same effect. It has to be relative motion between the conductor and the magnetic field. So you can move the magnetic field or you can move the conductor. And that's basically the way all generators work, is they have magnets and conductors, and they use something to move that magnetic field, to induce some sort of relative motion between the conductor and the magnetic field. You can do it with a water wheel, you can do it with a windmill, you can do it with all sorts of things. But basically that's how you can do it with a steam turbine that spins something that has magnets on it. So most of our that's right there is how most of our electricity is generated. That right there. Just moving magnets relative to conductors. There's a few things, like solar is different. But anyway, so that's what you're supposed to do. Just do a few different things and observe what happens. Take note of how large, whether or not there's a lot going on. Whether or not there's that's weird. I'm trying to draw, and for whatever reason, it's not letting me draw. See, that's me trying to draw. Just kind of move it around a little, kind of get a feel for which kind of movements induce more current than others. And that's it for that lab. Bye.